Students, the next topic is electrical and electronics measurement. That was a last topic which was remaining in the first module. So what is measurement? As we know, measurement is a act or a result of comparison between the predetermined standard and an unknown magnitude. We have a one predetermined standard, other jodiga unknown magnitude, and we are going to have a comparison. So the unknown things are being compared with the standard predetermined values. We have a particular standards, we have particular benchmarks. With those values we are going to compare with this unknown magnitude. We have two methods of measurement. One is direct method, other is a indirect method. What is direct? Here, in case of direct method, the parameters to be measured are directly compared with either primary standard or secondary standard. We are going to have a comparison method. By comparison, whatever the readings we are going to obtain, whatever the method we obtain, that is called direct method. So in direct method, basically comparison is used. Whereas in the indirect method, what happens? Here the comparison done with the standard by the use of calibrated system. We are going to compare, but with the help of calibrated system. That is, indirectly we are going to have the comparison. And next, we have three modes for measurement: primary measurement, secondary measurement, and ternary measurement. Next, correction. So what is static corrections? Static correction is the difference between the true value of and the measured value of the quantity. Original true value minus the measured value. So that the difference is called static correction. And next, what is range? Range is nothing but the difference between the largest and smallest readings. The largest value minus smallest value is known as the range. Next, accuracy. Definition. What is accuracy? Accuracy is nothing but the closeness with which an instrument reading approaches the true value. So what is the true value? Okay, there will be one particular true value. So for that true value, your readings, whatever the readings you are going to obtain, how much proximity, how much closeness your readings are there with respect to the original true value. Suppose think that the true value 10.00. You have taken the readings 9.1, 9.2, 9.3, 9.4, 5, 6, 7, 8, 9.8, 9.9. So 9.1 is very far away compared to 9.9. 9.9 is very close to the true value. So the more accurate is 9.9 compared to 9.1, like that. So what is precision? Precision is a measurement of reproducibility of the measurement. So it is a measure of reproducibility. So whatever the values you have obtained, to how far extent you can reproduce the values, that is called precision. Again, the errors are classified as a gross errors, and second is a systematic errors. The systematic errors in turn classified as instrumental, environmental, and observational error. Instrumental errors are present in the instrument. Environmental error is due to the outside environment. Observational error is due to the observational, because the person or operator, example is your parallax error. And random errors is due to unknown. We don't know why they are going to happen. Next topic, measuring instruments. So one example is a galvanometer. Now galvanometer is an instrument used for detecting the presence of small currents as well as small voltages. So galvanometer to measure small voltage and small currents. Whereas ballistic galvanometer is mainly used to measure the quantity of electricity passed through it. So to measure the quantity of electricity is being done by ballistic galvanometer. And we have a moving iron instruments which are used in laboratories as well as switchboards. And PMMC, permanent magnet moving coil, is a most accurate type of DC measurement. Point to be noted, PMMC is a most accurate type of DC measurement. And we have a point, next point, we have a three types of watt meters, and namely they are: number one, dynamometer watt meter, second is an induction watt meter, electrostatic watt meter, etc. What is induction watt meter? The induction watt meter can be used in AC circuits only. And next we have an energy meter. So energy meters are mainly used to measure the quantity of electrical energy supplied to the circuit. Next, measurement of resistance. How we can measure? Resistance are classified as low resistance, medium resistance, and high resistance. For balancing of an AC bridge, the two conditions should be met. Number one, magnitude of the impedances should satisfy the relation Z1 into Z4 equal to Z2 Z3. Also, the phase angles of impedance should satisfy the relation angle theta 1 plus theta 4 equal to theta 2 plus theta 3. These two conditions should be satisfied. So this is regarding electrical and electronic measurements, and now we shall continue with the next module, that is second module, DC machines and alternators. So in that we have a DC generator. What is generator? Generator is a machine which converts mechanical energy into electrical energy. We have two parts here, one the magnetic field and other is a armature conductor. Sorry. The production of dynamically induced EMF according to the Faraday's laws of EMI, electromagnetic induction. Here the dynamically induced EMF is produced because of Faraday's laws of electromagnetic induction. And we have armature windings of two types, lap winding and we have a wave winding. What is lap? Here back and front pitches are odd numbers and differ by 2, or we can say multiple, they are of opposite in, and second point, they are of the opposite in sign. And here both YB and YF, back pitch and front pitch, they are nearly equal to pole pitch, and average pitch YA equal to YB plus YF by 2, or that is equal to Z divided by P. And next we have a DC generator. We have two types, separately excited and self-excited. Again in self-excited we have serial wound, shunt wound and compound wound, and this compound wound has got long shunt and short shunt. Next, the generated voltage is given by Vg is equal to terminal voltage plus armature drop, that is V plus Ia into Ra. Also Eg equal to Zn pi divided by 60 into P by A. This is very important equation where A is a number of parallel paths. For lap winding A equal to P, number of poles, and wave winding A equal to 2. And the total losses in the DC generators are copper loss, iron loss and mechanical loss. Copper loss is again divided shunt loss, armature and series copper loss. Iron loss is has two types, hysteresis loss and eddy current loss, and mechanical losses are friction and due to windage. And next topic, commutation. So what is commutation? Commutation is nothing but a process of converting AC into DC, or the currents in the armature conductors are of armature conductors of the DC generator into unidirectional. So the currents in the armature conductors in the DC generators, actually they are in alternating mode, they have to be converted into unidirectional, that is direct current. For that purpose the commutators are being used. And next, what are the characteristics of DC generators? Number 1, no load saturation characteristics. That is, it is a relationship between the no load generated EMF in the armature and the field current at the fixed speed. Second one, total or the internal characteristics are the relationship between actually induced EMF and the armature current. And next, voltage regulation. What is regulation? It is the change in the voltage value when load is reduced from rated value to the 0, when the load has been reduced from particular rated value to the 0, and it is usually expressed in percentage of the rated load. That is, voltage regulation is in percentage. And in the next video we will continue with the DC motors.